Good morning, ladies and gentlemen. This is Mr. Rowe. We're looking in Geometry Part A. This is Lesson 18. And we're looking at how to prove that a parallelogram is a rhombus, rectangle, or square. So let's take a look at what we're trying to show. Remember, these are the characteristics of all three of these objects. So for a rhombus, we have that all four sides are the same. All four sides are congruent. The diagonals have to be perpendicular bisectors, and that the diagonals are angle bisectors. And these were theorems in the lesson. This was kind of the definition of what a rhombus was. So for a rectangle, we've got that it's a parallelogram with four right angles. So we take that parallelogram, we give it four right angles, we've got a rectangle. And the big thing for a rectangle is that the diagonals have to be congruent. So if we have congruent diagonals, then we know we have a rectangle. And a square is a parallelogram that has not only four congruent sides, but it also has four right angles. So a rhombus and a rectangle together make a square. And then all the characteristics of both a rhombus and a rectangle go together to make a square. So let's take a look at a simple proof and a little more complicated proof. So here's our first proof. We've got this parallelogram, ABCD. It's a parallelogram, and we have that AB is congruent to BC. We're going to prove that this is a rhombus. So let's always talk out what you're going to do and then start doing your work. So if I can show when I've already got that these two are congruent, I know that it's a parallelogram, so I know that opposite sides are congruent. So using this piece of information right here, I want to show that these opposite sides and these sides that are side by side are congruent using transitive property. And once I have all four sides are congruent to each other, then I have a rhombus. So here's our statements and our reasons. So we've got parallelogram ABCD, that's given. We've got AB is congruent to BC, that's also given. Now, once I have that, I'm going to use one of my theorems that says that the opposite sides are congruent. So I've got AB is congruent to CD. I've got BC is congruent to AD. So that was a theorem that we had in the lesson that the quadrilateral is a parallelogram and its opposite sides are congruent. Now, once I have that, I can apply transitive property. AB is congruent to BC. Right here, I've got BC is congruent to AD. So using transitive property, I can make these two congruent. Same thing for CD. I've got AB is congruent to BC. I've got AB is congruent to CD. That makes these two congruent. Using that, I've got those statements right there. That's the transitive property of congruence. And now I have that all four sides are congruent. I've got these two are congruent. That's these two side by side. I have these opposite sides are congruent to each other. We had the definition or the theorem right here to show that. And now we know that AB and AD are congruent. So AB and AD. So these two are congruent and these two are congruent. So I've got all sides being congruent. So now I have a rhombus, and that is by the definition of a rhombus. So that's how simple these can be. So let's take a look at one that's a little more complicated. And I say a little, it's a lot more complicated. So here is our given picture. We're given that we have parallelogram PQRS, and we've got the measure of angle QRS. I'm going to mark this one so we can see what we're talking about here. So RQS is right here. It's congruent to the measure of angle R, or not congruent, but equal to the measure of RSQ. So that's this angle. So we've got those two angles are equal. We're going to try to prove that this is a rhombus. Now, in order to prove that this is a rhombus, we can show that the diagonals are perpendicular bisectors. I don't think we have enough information here to kind of go that direction. We could show that all four sides are congruent. Well, we're not given anything about the sides, so that's going to be kind of a hard sell. So we do have this theorem that says that if an angle or if a diagonal bisects opposite angles, then we have a parallel or a rhombus. That's the way we're going to have to go here. So we're going to have to show that these two angles are congruent and these two angles are congruent. So how are we going to work all that out? Well, we know we have parallel sides here. So that's going to give us these two angles are going to be congruent. We also have that the opposite angles have to be congruent if this is a parallelogram. So we're going to show using angle addition postulate that these two angles are the same. And we're going to have to use some substitution to get around to that these two angles are congruent. So a lot of work here, so let's get started with this. So our first statement and reason, we got our given. We have our second given. So those are our given pieces of information. Now we're going to do the work here. So we're going to start off by saying that these two angles right here are congruent. So RQP is congruent to RSP. So I said PSR. So that's the same thing. So these two opposite angles are congruent. So let me mark that so we know what we're talking about here. So we've got this angle is congruent to this angle. I change colors so I don't have to put a bunch of marks here. So that's what we got with that statement right there. So that is if a quadrilateral is a parallelogram, then its opposite angles are congruent. That was in the last lesson. So the next thing we're going to do, we're going to talk about those angles. Well, those angles are these two angles added up. So RQS right here, RQS, and PQS right here. So this angle and this angle form that angle. Same thing down here. We've got PSQ right here, and RSQ. Those form this angle right here at vertex S, and that's by the angle addition postulate. Now, why do we have to do that? Well, we have to show, we're going to have to do this in order to get those pieces to be congruent. So we're going to have to use that to get to the pieces. So the next thing that we know is that I'm trying to get my laser pointer back here. So we got an RQP. RQP is congruent to PSR. And that's by the definition of congruent angles. So that comes back from this statement right here. So we have to use this statement here to now we're going to use this. So the next statement will be that those two angle addition statements that we made are congruent to each other, and that's through substitution. So we just put these two equal to each other. And yes, we have to make this statement in order to get to this statement. Now, what did I do here? I did another substitution. I went back to my given. I have my given right here. RQS is congruent to R or equal to RSQ. And I substituted RQS for RSQ. Now, if you look, we've got the same thing on both sides. So what that allows me to do is to use subtraction on this next step to get that PQS is equal to PSQ. So where are we at right now with this problem? So we've got RQS right here. RQS is congruent to RSQ. So that was our given. So those two red marks were our given. Now this tells me that PQS, so PQS is congruent to PSQ. So that's, and let me see if I can, I want to erase these now. And that piece of information tells me that this angle is congruent to this angle. Well, now, Mr. Rowe, you've got that the angles themselves are congruent. Why can't you just state it now? Well, I don't know that these angles are the same as these angles yet. I haven't said that. So I have to work some more to get that those two are congruent. So how am I going to do that? Now, this is where the parallel lines come in. I've got QR is parallel to PS. Now, why do I need that? And that's by the definition of a parallelogram. That's actually, yeah, that's a definition of parallelogram. So now I can use that to show that this angle is congruent to this angle. So you see, that's where we're going here. So we've got this other angle here. So I've got this angle right here will also be congruent to this angle. So that's going to be our statement here. RQS, right here, RQS is congruent to PSQ, and that's going to be by the alternate interior angles theorem. So now is where I'm going to use some transitive property or substitution actually to show that RQS is congruent to PQS and RSQ is congruent to PSQ. That's actually transitive property, like I said. So now I've got these angles are congruent. So using this statement, just like I did in the last one, I now have a transitive giving me both of these angles are congruent. And now I have that I have a rhombus, PQRS is a rhombus. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. Now this one is a detailed proof. If I gave you one like this, it would probably be a more fill-in-the-blank proof. But these are two proofs, kind of similar to what you're going to see in your assignment. I hope this helps you kind of think through the thought process of getting to the proof. If you have trouble with this, please let me know in a teacher message or make an appointment for a help session.